All right, welcome to today's webinar with FireTail. Today we're going to be talking about the 6 pillars of an effective API security strategy. We're going to try to keep this webinar to 40 minutes or less. Let's see how we go. But the 6 pillars that we're going to talk about today in some level of detail are discovery, visibility, observability, assessment, enforcement, and audit. And just as a quick bonus towards the end of today's session, we're going to talk about what doesn't work in API security and give some reasons for why certain traditional approaches to security don't really work specifically for API security. And with that, I'd just like to take a few minutes to introduce the speakers for today's session. So myself, my name is Jeremy Snyder. I'm one of the co-founders here at FireTail. And my background is in IT and cybersecurity going back about 25 years. The first half of my career spent as a practitioner day-to-day leading IT initiatives and cybersecurity efforts across a couple of SaaS companies and video game company before transitioning into more of a product-led role. And I'm joined today by Timo Rüppell. Timo, do you want to take a few minutes to introduce yourself to the audience?
Sure, thanks, Jeremy. Yes, I'm Timo, and my background is in theoretical physics, which I hope nobody holds against me. I have been in the startup game for at least over a decade, and I have built several API-centric products. I've been through security audits and have a fairly well-built understanding of security issues that affect API systems overall.
Awesome, awesome. And I know some of that experience that you bring to today's conversation is going to be especially relevant because you've lived a lot of this stuff firsthand, specifically as it relates to APIs. So I'm sure that you'll have some great insights to share with our audience today. So let's kind of start with the first real fundamental basic, and that is, to protect your APIs, you first need to find them. So what can you tell us about this topic and some of the things that you might share with the audience around API discovery?
Yes, so this is definitely one of the most important things about API security is just knowing what is out there. Many security incidents are basically a variation of, oops, we didn't know it was there. So you have zombie and outdated API versions that are just stood up and left there without being updated and having their vulnerabilities taken care of. You might have APIs that are stood up by dev teams as experiments and then just forgotten. This is a very common occurrence. You also have to take into account that modern applications are built in complex cloud environments where you have multiple accounts, network segments, and things just get lost easily. So with these sort of fast-paced changes in cloud environments, if you have a manual process that you're just keeping track of APIs that you're deploying with a spreadsheet, for example, it is extremely difficult to stay on top of what APIs you have deployed. So if you're a company and you're embracing DevOps and DevSecOps, it is extremely challenging to keep abreast of what you have out there. And that is really critical for security because one of the fundamental rules of security is that if you can't see it, you can't protect it.
Yeah, I think that's absolutely true. And, that kind of leads us into our next point around visibility. So, discovery is absolutely essential, as you mentioned. And what's the outcome of discovery? And the outcome of discovery is having that visibility. And when I think about visibility, I actually think of it as kind of a two-part thing. So one is that discovery we just talked about, and then two is keeping an inventory. There's a cyber hygiene is, I think, an often overlooked core principle of cybersecurity. If you know what's out there and you know the context of what's out there, that can be really kind of game changing in terms of understanding the risk associated to any particular API. So if you think about, for instance, what cloud account an API lives in, whether it's an internal API versus an external API, or an API specifically used for interactions with one particular partner, those have different levels of risk associated with them. And so having that visibility and awareness around the context of an API is very much a critical aspect and a critical benefit that comes from that visibility. The second aspect of visibility that I really want to emphasize is, along with that context, you need to see into the application layer. And we're going to talk a lot about that as we get further into today's conversation. So on that point, context is critical, I think is the key highlight that I would say there. And if we think about looking at, let's say, a sample cloud architecture that we've got here, this is just a reference architecture from, this one happens to be from AWS, but it really applies equally to any of the cloud environments. You see here that we've got a real variety of compute infrastructure components, everything from things like workflow engines, we've got serverless platforms, we've got containers, but we've also got multiple interface points, right? We've got interfaces that are outward facing, going to end users and applications, but then we've got interfaces and connections that are back to corporate data centers or to a corporate office over a private API gateway and a VPN. And so again, the level of risk for any of those kind of connection paths would be very different. And understanding that context when you get the discovery process that leads to the visibility is going to be very important for any organization to try to understand. So next, I want to talk about, once we've got that discovery and visibility going, let's talk about observability. What can you share with us about observability, Timo?
Sure. Like the main thing here is that once you do have visibility, the next thing is to actually understand what is happening in your infrastructure, like with your deployed API real estate. So you need to get understanding about how these APIs are used, what is their expected usage patterns, what kind of types of APIs are there, and how is the data processed that these APIs are shunting back and forth. So this not only helps you obviously with performance related improvements that you can make, but it is also a critical aspect of security where changes in usage volumes or changes in the way that data is suddenly processed can indicate that something serious is happening. So actually, like the combination of these three items, discovery, visibility, and observability, are just fundamental for being able to then get a very good picture of what is actually happening, and then using that to define what you want to happen, which then turns into the actual governance of your APIs, which is the next thing that we want to talk about.
Yeah, and I think, that point is really well taken, that, governance is kind of what you want to have. And then having that governance should actually lay out a clear path for developers and for the organization as a whole in terms of, let's say, launching new APIs and the desired configurations and the desired security controls around any of those APIs. And so when I think about that, the thing that comes to mind mostly on the basis of everything that we've talked about so far, kind of that discovery, visibility, having contextual awareness, and then having observability, is to then assess APIs. And assessing APIs, I think of as kind of a two-part thing. So one is understanding the risk or the threats around an individual API, which is partially informed by the context of the API and partially informed by things like, let's say, an OWASP API top 10 list that describes the common and the most exploited attack techniques against APIs. And so when we looked at assessment and we thought about, what are the types of assessments that can be most impactful for an organization implementing an API security strategy, it really comes down to a few things. One is examining the specification of the API itself, which is really kind of the basis of describing the desired behaviors of an API. Where should an API be accessible? What actions should be possible to call and implement? And how should an API, let's say, be authenticated or API usage be authenticated? Second, we look at kind of security configurations in the environments around the API. And that might have to do with things like network infrastructure that an API sits behind or communicates through. And so that is that assessment step. And I think of this as really, the outcome of an assessment should be to tell you where you have very specific kind of line by line, point by point risks or misconfigurations around an API that you might want to deal with. And ultimately, what you should have from an assessment process is you should have a continuous feedback loop inside the organization. So APIs get designed, they may get tested in kind of development and staging environments before they go into production. But once they're in production, they get observed, as we talked about in our previous observability step. And the observations combined with this assessment can then feed back to the people who can actually make improvements to the APIs, which in most organizations is going to be the development teams who own those APIs. So Timo, let's talk about enforcement.
Yeah. So this is like the other side of the coin, what I would say to what you've just been talking about, where the enforcement of the functioning of an API is what we call a runtime protection, meaning that not only is your API configured in the correct way, deployed in the correct way, and changes are managed in the correct ways, but now you actually get into the details of having a specification document that lets you dictate how the API should actually behave. Like, how does it actually process the data? And this runtime protection needs to be in the runtime. So there are traditional security methods like having a WAF or having API gateways. And these are very useful in limiting certain types of attacks. But as we have discovered, and as it has become obvious when you look at the OWASP top 10 rules, for example, a large part and the top 3 threat vectors are authentication, authorization, and poor data management by the API, which are logical problems that can't really be dealt with at the network layer. So to align the enforcement with your desires, you really do need to have a mechanism for enforcing the API behavior at the application layer. And this can generate a sort of zero trust model with your API where you have like a safety cushion or a safety net to catch misbehaving API behavior.
Mm. And so really on that zero trust model point, I just want to dig into that for a second. If you think about something like an API specification, that should really describe the only acceptable type of communication and interaction with an API, if I understand that correctly, right?
Exactly. So you have things like, I mean, the king of the hill is open API specifications, which distinctly this a listing of the allowed responses that the API is supposed to give. They detail the parameters that the API is supposed to consume, and they can have very strict definitions for those. And any sort of deviation from those can then be effectively blocked and or at least alerted on. So you get a very good picture also just for how your API is working.
Yeah, awesome. I know that jumping to runtime protection on day one for a lot of organizations can be a little bit of a challenge.
Yeah.
So maybe talk for a second about the kind of the adoption path that we tend to see with organizations as they do embrace an API security strategy. How have we seen
Yes.
that play out?
So, I mean, obviously, as we've discussed, the very cornerstone, the foundation is discovery and inventory. So that is where most organizations just start off, and then they discover that they actually have maybe more APIs that they actually knew about before, and so via this observability, they then can formulate policies for how these APIs should behave, and they perform assessments and slowly move from that policy stage then into attack prevention and also getting centralized auditing in place. And that sort of brings the governance aspect of API security into play, which is sort of the end goal for most organizations, to have a sort of fully protected and well-managed API.
Yeah, and on that point, let's talk about audit trails for a second. And I know the question comes up a lot of the times, why are audit trails important and what can we actually do with an audit trail? So I wanted to take a minute to kind of talk about that. And There's a couple things that we've heard pretty consistently in talking to organizations around auditing API activity. And one is that, continuous monitoring assessment is something that generally people like to do from a security perspective. They want to understand what's going on. One of the challenges around APIs is if we think back to that cloud architecture that we looked at, that was a one simple architectural example, but it showed multiple API interface points, and it also showed the multiple compute environments that are pretty common in modern cloud platforms. So what that means, though, from a audit trail perspective, and why that's a challenge, is that all of those things log to different locations by default, and the layers of visibility that you get from those different log file types is quite different. So creating a centralized API audit trail is not very easy if you don't kind of look at some instrumentation or telemetry data around your APIs. Second is that if you just try to log from various different data types and various log types into one central location, and you've got this kind of data irregularity, and you then try to put in place alerts on top of that, you tend to go with the least common denominator, which is that you put in place alerts around any kind of potentially malicious condition, and that leads to a really high level of noise and the classic alert fatigue symptom that we see from a lot of organizations where they're just overwhelmed with alerts that turn out to be mostly false positives, and it's just kind of novel behavior of an API where they don't necessarily have runtime protection that might have blocked a potential threat or something like that. And the last thing I want to stress around this is from a compliance and regulatory perspective, a centralized audit trail for your APIs is crucial. One is to just understand that and to then pass things like regulatory requirements, SOC 2 audit, HIPAA, PCI, et cetera. But another is that increasingly what we're seeing from governments around the world is more legislation and more kind of regulation around the reporting of cybersecurity incidents. And if you either don't have a good level of visibility or you don't have a centralized audit trail, it's going to be a very difficult exercise to try to understand the scale and the scope of an API breach if and when that day does come to your organization. And so having a central audit trail of all of your API activity with kind of a common structure around the log data makes it very easy for a security team to understand what is going on, to apply the right thresholds for where to generate alerts and notifications aligned to the risks and the threats of those particular APIs or those context environments. And then, of course, on terms of reporting and in terms of disclosing breaches, you've got great data to start with. You can automate a lot of that, in fact, and you're in a really good position for, if and when that day does come. All right.
Okay, Jeremy.
So,
I know you want to go for this. No, I know you want to go for this. You have some ideas for what doesn't work.
Yeah, I mean, I'll start it off and feel free to chime in because we hear a lot about like, okay, that's all well and good. Let's just apply anomaly detection across the board because we've got so much happening in our API environment, and a lot of organizations that we talk to are in the millions, if not tens or hundreds of millions of API calls per month or per week. The challenge around anomaly detection is kind of twofold. One is that if you think about high volume APIs, how do you distinguish a very successful service from a service that is actually under attack? So that's one challenge that we've seen. The other one is if we think about kind of anomaly detections in high volume environments, I'll just take a tangent for a second to try to kind of explain why it strikes me as being an ineffective algorithm around this. I worked for a while with an organization that had a very fast growing managed detection and response business, MDR as it's often called. And what MDR is really built on is collecting logs from all these various sources. Usually that's from like endpoints and networks and user behavioral activities and things like that. You bring them all into a central location and you try to do correlation across the different data set types. And then you look for potential conditions that indicate malicious behaviors or attacks or breaches or what have you. I talked to a bunch of the SOC analysts from that team, and I asked them how they're dealing with the volumes of data that they had and what they were doing. And they described some of the different approaches that they had, some technical, some human oriented, some things where they had a process in place to kind of deprioritize certain types of tickets. But the long and short of it was they definitely had anomaly detection algorithms on a lot of the log types that were flowing in. And when you ask them how effective it is, you find out that actually it's like 80% or higher false positive. And what that translates to is kind of 30 hours out of a 40-hour work week spent chasing down things that end up being, okay, this is just something we haven't seen before, but in the end, it was fine. And so, like anomaly detection as the basis for an effective API security strategy, I don't think is effective. I do think there is a place for it, and I think it can be supplemental to any of the things that we've talked about today, and it can be potentially an initial signal type on top of things like runtime protection. But as a core strategy on its own, I think there's a real challenge around anomaly detection. Does that kind of make sense, Timo?
That makes absolute sense. That is very true. And now I want to point out, like, I want to maybe stress one additional thing, that is the thing that already earlier mentioned about attacks being logical. This is a thing that really is sort of my pet peeve, because there are dozens of things that you do in a normal API deployment that are sort of security best practices, like you use SSL, you use WAFs, you use gateways, and none of these sort of like traditional network security issues help against these what we are seeing, new types of attacks, which come in with a token that was leaked, and then exploit vulnerabilities in the business logic that gives them access to stuff that they shouldn't have access, or even lead to privilege escalation attacks. So this really, I think, is the sort of thing that many people maybe don't yet realize when they look at these incidents where millions and millions of data records are being lost. Like a WAF will never protect against those, because the people who are exploiting these vulnerabilities, they're just slowly leaking the data. There's no sort of DDoS aspect to it, or there's no massive data exfiltration going on. It's simply that there is like a small sort of error in the business logic that lets, Joe, whose computer got taken over, actually see, everything that's in the system, for example. And this is something that I feel needs a lot of attention still, and sort of also maybe education on everybody's part.
Yeah, it's a great point. And I mean, I think that point about the attacks being logical is one that is not widely understood, perhaps outside of the community of those who are really heavily focused on API security as we are. Our own research around it, to your point earlier, does kind of clearly illustrate that the top three attack vectors are authentication, authorization, and data management, all of which are logical constructs of an application. And so to anybody who's watching this recording and hasn't perhaps seen a couple of webinars ago, we actually did a webinar around the state of API security, and we talked about the findings of our research and the summary of about 10 years of API data breaches. Feel free to go back and look at that, and you'll see very clearly the data does illustrate that those three attack vectors alone, I think, make up something like 75 to 80% of the breaches to date. And to that point, a WAF or an API gateway, it's going to look like normal API traffic. So that is one of the real challenges. So I want to transition into just sharing with our audience a little bit about FireTail, how we built it, why we built it, what have been some of the core design principles. And I think FireTail really is built on these 6 pillars of an effective API security strategy that we talked about: discovery, visibility, observability, assessment, enforcement, and audit. And to that end, what I'd love for us to do is to actually walk our audience through a couple of those things. So we're going to turn over the screen share to you for just a second, Timo. There we go. Awesome.
Yes. All right. So yeah, this will be a sort of brief walk through our application and sort of keeping in mind like how we have built this around these pillars of security that we just went through. So starting with discovery, this page is our integrations page. As a SaaS platform, what we are here to do is we're going to help you discover all of your APIs regardless of where they are sitting. The main tool for this is our cloud integration. So we have AWS, Azure, and GCP. We also have a GitHub repository API discovery tool that you can either use for scanning your repositories and letting us discover APIs that are being developed there. We also have a GitHub action available that you can use in your CI/CD pipeline for then not only discovering, but also updating your API specifications. And this really is intended to let you easily set up your, for example, Azure integration. This is targeted to take about 5 minutes so that you can create a free account, for example, and test this out. You can use this to either discover your AWS or Azure or GCP APIs, and that will then lead to the next page, which is, sorry, I'm going to take this other place here. We're going to see all of your APIs that you then get. So this should fill up with the APIs that you have deployed in your environment. And here you can see you can filter by the various types of APIs that are here. This is our testing environment, so there are a few of each of them here in this view. So what this then leads next to is observability around these APIs. So you can, for example, go into one of these APIs here, and then you can start seeing the kinds of requests that have been made. You can see all of the details around these requests, including execution times and response and request payloads. We do some log enrichment around findings of what is happening in this specific API request, for example, and this allows you to get like a good understanding of what is actually happening with your APIs here. The next step after that is then posture management, which will let you actually see what kind of state your API is in. So for example, here we have some events where a collection version has changed. So an API has been updated, the specification file of an API has been updated. When that happens, we find this via the cloud integrations or via the GitHub integrations, and we run an analysis on that API for common misconfigurations, things that might be wrong with that, and we give you a very good overview of what has happened. So here, for example, we see all of the different kinds of findings that we have regarding this change that happened. We can also sort these by severity, and we see that there's even a critical one. With these, we try to give you some very good context and information about what actually has happened here. So this is an endpoint that we detected, which does not have security implemented, but which previously had security implemented. So this should be classified as a critical finding from our point, because something definitely has changed, and maybe this is an accident in your development pipeline, for example, that the security methods have been removed from this API. So this is sort of the posture management side, where we observe changes for sort of the API specifications. The next thing that I can quickly show is actually the enforcement side, if that is possible, this will be a very quick demo of our library integration. So we provide a variety, for a variety of programming languages, software libraries to help you use API specifications in enforcing the API's expected behavior. So here we can see that we have an API specification file, and we have a separate sort of security section that is an extension which lets us sort of figure out the sort of authorization for this endpoint. So in order to demo this, the endpoint will be serviced by this function here. And as you can see, this is an unconstrained data return. So we are just getting the pet for the correct ID and then returning this pet. And this is now intentionally very, very unsecure. And you see that we have two different pets in our data. We have a single cat that has an owner ID of 1, which will be the incorrect owner ID. And then we have a dog, which will be the correct owner ID. So let's hop over to Postman and see what this looks like. So here we have Postman, we are hitting this endpoint and we are passing along the pet ID 11. And we see that we have failed. And well, we shall look at the actual documentation here. Now we see that we actually got a 304 here, and we can actually see what actually happened. And we see that the response data here, the body where we return the error for the authorization is here. And here we actually see that our library blocked this incorrect original body where we would have otherwise returned the cat that is incorrectly owned by the wrong owner. So when we go here into Postman and try to fetch the dog, we see that this works just fine. Then there are additional ways in which we can deal with this authorization. If you, for example, have a more complicated method for figuring out the authorization graph, then you can integrate with third-party providers or even host your own authorization graph via OpenFGA, for example. For this, I would invite anybody who's interested in to book a demo because they can get quite technical and quite complicated, but we're happy to share and happy to show this to people who are interested in this. Yeah, maybe last is then like the dashboard, which sort of gives you a nice combined overview of what is happening with your real estate, and sort of lets you also then see and track what is happening overall in your API deployment.
So that's kind of that central audit trail of all of the API activity across your environment. Yeah. You've got the various endpoints and all of the HTTP responses from that. Awesome, awesome. Well, I will, kind of flip back to wrapping up today's session, and hopefully, for those that are watching either live or after the event, hopefully that was a quick demo walkthrough that tried to illustrate to you the strategies on which FireTail is really built. And, it's really designed again around that question of the 6 pillars that we talked about. And that demo, as you saw from Timo, really starts by going through the kind of discovery, visibility, observability, assessment, protection, and audit. And great. And so just kind of wrapping up, I do want to put this offer out there for anybody who's watching today's webinar, either live or after the event. We are offering a free tier of FireTail for any SMBs and startups. For those that are interested, please feel free to just follow the Get Started link from the top of our website, firetail.io. And for any enterprises that are looking for the kind of business plan features that you get on top of the startup free tier, please just reach out, or you can also start a free trial there directly on your own. Again, my name is Jeremy Snyder. I'm one of the co-founders here at FireTail. I want to thank everybody so much for taking the time to join us on today's webinar. And with that, Timo, thank you so much for sharing all of your valuable information with our audience, and we will call it a session on today's webinar. Thanks so much. Bye-bye.
Bye-bye.